So 15W minus 3V. It's the biggest number that goes into 15 and 3. 3. How many terms are going to be inside? 2. So what times 15? What times 3 gives you 15W? 5W. And what times 3 gives you 3V? Just V. Okay, you gotta watch your variables too. All right, watch your variables. Okay, everybody good? Second one: 7x squared y squared plus 21xy squared minus xy. GCF out of those would be what? 1 what? 1xy. Okay. Even though your numbers don't work, you definitely have variables that can come out of there. Okay, I can see how each one has at least 1x and 1y in it. So you can at least pull one of those out. Alright. Which leaves you with 7xy plus 21y minus 1. Okay, questions on that? Everybody good? All right, next type of factor we're going to do is called by grouping. Okay, this is a little more complicated. It's not terrible though. It's a lot harder in Algebra 2 than it is here. These are going to be your basic easy ones, okay? You can do by grouping only when you have 4 or more terms. In most cases, more cases than not, it will be 4 terms. Bullet number 2, terms have common factors that can be grouped together. I'll show you what that means in a second. And number 3, there are 2 common factors that are identical or additive inverses of each other. So look down here at the symbols. You have AX plus BX plus AY plus BY. These first 2 terms have what in them? They have X's, so they get grouped together. These second 2 terms have what in them? Y's, so they get grouped together. Okay? And since they have each of one of these first 2 terms has an X in common, you can take that out. X parentheses A plus B, like we just did. Right? With greatest common factor. Same way with your AY and BY. You have Y's in each. So you can take one of them out. Okay? Now, between these 2 lines, X parentheses A plus B and Y parentheses A plus B, what did each one of these have in common? They have A plus B in common. So since that's the case, you can take one of them out and write it X plus Y together, like that. Okay? See it in action. Ready? Number 1. 4QR plus 8R plus 3Q plus 6. Your first step is to group them together. Group these 2. Group those 2. Notice where I put my parentheses. Okay, see that? Right there. Okay, now, what's the GCF out of 4QR and 8R? 4R. Okay? 4 is the biggest number that goes into 4 and 8. And each one of those parentheses, each one of those have an R in them. See that? So your greatest common factor is a 4R. Which leaves you with what?
4Q.
Nope. Q.
Oh, and 4.
Q plus 2. Because remember, you got to distribute this back into here. Okay? See that? Now go to your second one. What's the big GCF out of 3Q plus 6? 3. Which leaves you with what? Q plus 2. See how these binomials end up being the same thing? It has to be. Okay? It has to be, otherwise it does not work. Okay? From here, you take those two, and basically what you do is you factor them out. So you make it Q plus 2 times the outsides, 4R plus 3. And you're done. Okay? What's GCF out of the first group? Now, before okay, hang on, slow down. Remember what I said last time? I said, notice where I put my parentheses, right? When I grouped them? I put them here, and then I put them right after that term. And then I did what? I started them right there. So the second sign is the first sign of the second group. See that? Or the third sign if the first one would be a negative, but that would never happen. Okay. So, what is the GCF out of 2mk minus 12m? 2m. Leaving you with k minus 6. All right. Now, everybody good with that? Great. What's GCF out of the second group?
7.
Okay. The way I just taught you, 10 minutes ago, I taught you 7. Okay, so I'm going to put plus 7. Which would leave you with what?
A positive K. Or no, yeah. Oh, you put a negative K.
It would leave you with a negative K plus 6. See that? Because you have to distribute this back into here. Now, hold on. Don't erase. Don't erase some of you crazies. That's right. These two binomials have got to be the same. But you also have got to factor something out that makes them the same. So what should I do to my 7? Make it negative. Okay? Make your 7 be negative. Because negative 7 times what gives me negative 7k? A positive k. Negative 7 times what gives me a positive 42? There's your two same binomials up there. Okay? You rewrite them as 1? No. He missed the sign in the second one. Okay, now, before we do this, hold on, slow down. Before we do this, I got another question. Two x minus 8 equals 20. What do you do first? Add 8 to both sides. Gives you 2x equals 28. And then you divide by 2 to get x equals 14. Okay? Now, why is 14 the answer? And please don't say because you just did it.
Because 2 times 14 minus 8 is 20.
Good. Because 2 times 14 minus 8 gives us 20. 14 is the only number in the world you can plug back into x and get 20. That's it. That's why equations work the way they do. There is one and only one number that works. Now, x plus 6 times x minus 15 equals 0. I'll give you about 3 minutes. Figure it out. Okay. Who thinks they got an answer? Humber. 4.5. Let's say no. Reyes.
X equals 15.
15. Why do you say 15, sir?
I don't like negatives.
Good enough. 15 is correct. Okay? 15 is correct. Anybody still think they're pretty adamant about having something else, though? Besides 15? Federico.
I don't know what I'm supposed to get, but I don't know how I'm supposed to
I'll show you in a sec. Don't worry. Okay? But does anybody else think they had a right answer?
I read the question wrong.
That sucks. Okay? Let me show you why Mr. Reyes' 15 works. Okay? Now, I did not intend anybody at all to do like any kind of algebra, any foiling, nothing. The point is you want to make the equation be what? True. Okay? Now, to do that, what operation goes on right here?
Multiplication.
Multiplication. Okay? So, if I got myself in Mr. Reyes' mind, I'm thinking that he thought, hey, what time minus 15 is going to give me 0? And in that case, that would be what? 15. 15 minus 15 equals 0. What's 15 minus 15? 0. And what's x plus 6 times 0? 0. So 0 equals 0. Is it true? Yes, 15 works. $15 is not the only number up there that gives you a 0. The 6 of you that are playing games, no wonder you can't figure that out. Because you're staring off into cyberspace. Yeah, I'm not an idiot. I know. Probably sitting here silent, like, what's he doing? I'm waiting for you to figure something out up here, okay? Where'd you go and get negative 6 from?
Because you have to cancel out that 6 to get 0.
Yeah. Just like Reyes went with 15 on the left-hand side, or the right-hand side. Grellner went with negative 6. You know, Reyes said he didn't like negatives. He's right. But you get the same thing. You get it true. So your two answers here are what? Negative 6 and 15. Congratulations, people. You have moved on from one-answered equations. You have now moved on to 2. Why? Federico. You have 2 binomials up there. And when you have 2 binomials touching, that means you have what? Multiplication, okay? Now, those of you that foiled, when you did x times x, what did you get? X squared. That exponent of 2 is the reason why you have 2 answers. Okay? Because of that multiplication. We're going to go into more detail about that later. Alright? Like next couple lessons after the test. Alright? Now, how you actually can look at this and figure these out is very, very simple. You don't have to sit there and stare at it and go, okay, this and this and this. No, there is an algebraic way to do it. Alright? Basically what you did is you took each individual binomial and figured out what made it what? True, specifically though, number-wise. What number did you make them binomial? 0. You made them binomial 0. Okay? That's the same thing. This one, 2d plus 6, you want to figure out what number makes 2d plus 6 equal to 0. How'd you get that? No, don't tell me just looking. Algebraically. What do you do? Because sometimes it may not be so obvious. Reyes. Nah, not substitute, but I'm going to subtract.
Subtract 6 and divide by 2.
Subtract 6. Divide by 2. So that's what makes the left binomial 0. So that's one of your answers, -3. Do the same thing to the right. 3d minus 15. Add 15. Divide by 3. 5 is what makes the right-hand one be 0. You have 2 answers. 2 possible numbers that make you have a true statement. That's all you care about. You don't care. It's not the fact that you always just want one number. It's how many numbers give you a true statement. It used to always be 1. Or all of them, or none of them, obviously. Now it's 2. Mr. Wilson.
Are we going to have to show our work like that, or can we do
As, I'm going to go with the easy answer here, yes.
Oh.
Peterson.
What if it's, like, will it always equal to 0?
Yes. You always set those equal to 0, yes. It's a 2-step equation. At least I'm not making you show the many steps. The -6 divided by 2 anymore. See that? Notice how we've grown up? I don't do that crap no more. Yeah, you're a big kid now. All right? Everybody good? Uh-oh. A little weird now. The first two each had what in common? They were each equal to 0. So chances are we should probably make this equal to 0. How are we going to do that? Subtract 3c. So c squared minus 3c equals 0. Okay? Now, what else was true about the first two examples that is not true about this one yet? There's an operation that we are missing, that we need. Otherwise, it doesn't work. We're missing a multiplication. Okay? See that? We have a subtraction between two things. C squared and 3c. We need it to be a multiplication. So how can we turn a subtraction into multiplication? Starts with an F. 6-letter F word. Factor. Factor. What can you factor out of c squared minus 3c? A c. Which leaves you with c minus 3 equals 0. Because the whole premises of this problem fixates on the fact that something times 0 gives you 0. Okay? So if you don't have a multiplication between these two right here, like you do up here, see that? See how it's a subtraction between two things? I get that that's multiplication. I get that. That's not going to help you none. It has to be a multiplication like this with parentheses. See that? Okay. Now you can figure out what two numbers you plug in to give you 0. Okay? C minus 3 equals 0, so C equals 3. What else can you plug in? 0 itself. Why, Wilson?
Because 0 minus 3 is negative 3, and then the other 2 multiply it together. It's 0.
Right there. That's C on the outside. You set it equal to 0 outright. Okay, everybody see that? All right. 3x times x plus 2 equals 0. Split off your multiplications. 3x equals 0. X plus 2 equals 0. The left equation you divide by 3, so x equals 0. The second equation you subtract 2, x equals negative 2. And there are your 2 answers. Okay? 2 answers now. Getting bigger. The second one. Make it equal 0 first. You have to do that first, so we're going to subtract 40b. So 8b squared minus 40b equals 0. And then what's the GCF to factor out of those two? 8 what? 8b. Okay, 8b, which leaves you with b minus 5. Yeah, okay. Equals 0. And then set it. See how it sets up to one like we just did up top? See that? Okay, sets up to this. It has to be set up like that. Okay, if you're not set up like this, it's not going to work. Split it off. I'm going to go over here to the right of it. 8b equals 0. b minus 5 equals 0. Divide by 8. Which gives you b equals 0. Add 5. b equals 5.